everyone, welcome back. So today, we're really diving deep into a question that just keeps coming up in AI, and that is, can AI actually remember like we do? You guys sent in this super interesting research paper. It's all about TransformerFAM, and it seems like it could be a big step in that direction. What do you think?
Oh, absolutely. It's fascinating stuff. This paper really gets into the nitty-gritty of making AI more human-like, at least when we're talking about memory.
Yeah, because right now, you know how AI models are like amazing at just spitting out facts, like they've got this massive digital brain crammed with encyclopedias.
Right.
But then sometimes it's like they totally forget what we just said like 2 seconds ago.
Exactly. It's like they've got that long-term memory down, storing tons and tons of data. But when it comes to working memory, the kind we use to connect ideas in the moment, like remembering what someone said earlier in a conversation,
Right, right.
yeah, that's where they struggle.
It's like they can ace a trivia night, but then they can't follow a complex argument, you know?
Exactly.
So is this Transformer fam thing, is that what they're trying to fix?
That's the goal.
Hmm.
And their approach is really interesting. So instead of just processing information in a straight line, they've given the AI something like a feedback loop.
Okay, so instead of just like input, output, it's almost like it's whispering to its future self, keeping track of what it's learning as it goes.
That's a great way to put it. Imagine like the AI taking mental notes while it's processing information. So at each step, it creates this compressed summary, kind of like a little mental sticky note of what it's learned so far. The paper calls these feedback attention memories, or FAMs for short.
So it's not remembering every single detail, it's pulling out the important stuff, the gist of it all, to make sense of things.
Exactly. And the really cool part is that the AI actually uses these mental notes to help it understand new information coming in. It's constantly building on what it's already learned, just like we do.
That actually makes a lot more sense. But how does this play out in practice? Is it just about like AI churning out even longer essays now?
No, it's so much bigger than that. This isn't just about scale, it's about how these models actually think.
Mm.
Imagine chatbots that actually remember your preferences, or AI assistants that don't just summarize complex reports but actually pull out the important insights. Or even AI that can reason and solve problems step by step, just like a human would.
Okay, now those are some applications that like get my inner techie really excited. But how do you even test this working memory for AI? It's not like you can just give it a pop quiz, right?
Right. But they really put Transformer FAM through his paces with some clever tests. One they use is called passkey retrieval. Basically, they give the AI this massive wall of text, and hidden somewhere in that text is one crucial piece of information, the passkey.
Oh, wow.
It's like trying to find a needle in a haystack, but the haystack is a digital library.
Oh man, that sounds brutal. So how did it do? Was it able to actually find that passkey consistently?
That's where it gets really interesting. Transformer FAM completely blew the competition out of the water. Even when the document was insanely long, like trying to find a single sentence in a stack of books, it was able to pinpoint that passkey with incredible accuracy.
Wow, so it's not just remembering, it's remembering what's actually important, even when it's buried under a mountain of other information. But what about something a little more, I don't know, nuanced, something that really tests its understanding?
You're thinking about what the paper calls long context tasks, right? Tasks that require more than just remembering facts, like understanding a story, the relationships between the characters, the nuances of language.
Exactly. Like instead of just asking what color was the house, they're asking why did the character decide to leave home? Those kinds of questions require deeper understanding.
Exactly, you got it. And that's where those mental notes, those compressed summaries, really come into play. Because to answer those kinds of questions, you need to be able to connect the dots, just like a human would.
Okay, so spill the tea. How did Transformer Fam do? Was it able to keep up with those more complex tasks?
It did really well. Now, the gains weren't as dramatic as with the passkey retrieval, but it consistently outperformed the traditional models. It's like comparing a student who just memorizes facts to one who can actually understand and apply what they've learned.
So it's not quite ready to write the next great American novel just yet,
Right.
but it's definitely showing signs of being a much more sophisticated reader than what we've seen before.
Absolutely. And what I think is really cool is that the researchers didn't shy away from the limitations. In fact, they dedicated a whole section of the paper to what they called don'ts, things they tried that just didn't work out as planned.
I love that. It's like they're giving us a behind the scenes look at their process, the successes and the failures. It makes it feel much more like a real journey of discovery, you know?
Definitely. And they really experimented with a bunch of different variations of TransformerFAM, trying to like fine-tune its memory and its processing
So
abilities.
they were really in the lab, like tinkering with all the knobs and dials, trying to unlock the secrets of AI memory.
Exactly. And some of those experiments led to dead ends, but others revealed some really interesting findings. For example, they tried something called feedback memory segments. It was like trying to hand off the entirety of what the AI had learned at each step instead of just a summary.
So instead of just like passing the baton in a relay race, they were trying to hand off the entire track and field.
That's a great way to put it.
Hmm.
But it turned out that approach wasn't actually as effective. It seems like having those compressed summaries, those distilled nuggets of information, is really crucial for TransformerFAM to work its best.
It's like our own brains, right? We don't remember every single detail of every experience. We extract the most important parts, the things that really matter.
Precisely. And that's what makes this research so exciting. We're starting to see AI that doesn't just store information, but actually understands it, using it to navigate the world in a more human-like way.
Which I guess brings us to the big question. Does this mean we're on the verge of creating machines that can truly think and remember like we
Oh,
do?
that's the million-dollar question, isn't it?
Yeah.
And while we're not quite there yet, this research definitely gives us a lot to think about.
And on that thought-provoking note, we're going to take a quick pause. When we come back, we'll dive into what this research means for the future of AI, and we'll explore some of the mind-blowing possibilities it unlocks. All right, so we've established that this Transformer FAM thing, it's doing some pretty impressive stuff, like when it comes to remembering and processing information. But where does this actually take us in the future? Are we about to have, like, robots quoting Shakespeare and debating philosophy?
Well, maybe not quite yet, but this research definitely points to a pretty big shift in how we're thinking about AI. Like up until now, it's been a lot about brute force, right?
Right.
Bigger models, more data, faster processing. But TransformerFAM, it suggests that real intelligence, like true intelligence, might need something more than that.
It's like we've been trying to build this super brain by just like throwing more RAM and processing power at it, but we haven't quite figured out the software yet, the way it actually learns and understands.
That's a great analogy. And TransformerFAM suggests that maybe we need to look beyond just scaling up these existing architectures. Like maybe we need to fundamentally rethink how these systems process and retain information. And that's where things get really interesting because it brings us to the human brain.
Because our brains are like incredibly efficient at handling information, right? We're constantly bombarded with all this sensory input, but we're able to just like filter out the noise, focus on what's important, and make decisions in a split second.
Exactly. And that's what makes this research so compelling. By studying how biological brains have solved this whole problem of memory and learning, we might be able to unlock entirely new approaches to AI development.
So instead of trying to build a robot brain completely from scratch, we're starting to peek under the hood of like the most complex information processor we know of,
Yeah.
our own brains.
Exactly. And TransformerFAM, with its feedback loops and its ability to distill out that key information, it seems like it's taking inspiration from that biological blueprint.
It's like we're finally starting to bridge that gap between like neuroscience and artificial intelligence. That's pretty cool. But if this research is mostly focused on text, how far can we actually take this whole idea of AI with working memory? Could we ever see it applied to like images or even sounds?
Now that is the million-dollar question. And it's definitely one that researchers are already exploring. Like, imagine AI that can process video in real time, not just recognizing objects, but actually understanding the events that are unfolding, learning to anticipate what might happen next.
So like instead of just seeing a ball flying through the air, it understands that someone threw it and it's about to hit something.
Exactly. Or think about AI that can listen to a piece of music and not just like identify the instruments in the melody, but actually feel the emotional arc of the piece, understanding what the composer intended.
That's almost like science fiction. But if we can actually teach AI to remember and understand the way we do, those possibilities really are endless.
That's what's so exciting about this field. We're really just scratching the surface of what AI might be capable of.
It's like we're standing on the edge of a whole new era of intelligent machines. But as with any new technology, there are always going to be challenges, right? Ethical considerations that we need to think about.
Absolutely. And as we continue developing AI that's more sophisticated, more capable of learning and adapting, it's so important that we do so responsibly, with a keen awareness of the impact this could have on society.
It's a conversation we really need to start having now before these technologies become so advanced that they just kind of sneak up on us.
I agree. We need to make sure that AI is developed and used in a way that actually benefits everyone, not just a select few. And that requires a collaborative effort, not just from scientists and engineers, but from ethicists, policymakers, and just the public in general.
It's a complex issue, but definitely one that we cannot ignore, because ultimately the future of AI is in our hands. It's pretty mind-blowing to imagine, like, AI actually understanding music or being able to predict what's going to happen next in a video, just like we do.
It is.
But going back to the research paper, they did mention some limitations with this whole TransformerFAM thing, right?
Yeah, for sure.
It's not a perfect artificial brain just yet, or is it?
Well, it's definitely a huge step forward,
Right.
but you're right. The researchers were very upfront about the fact that, they're still figuring things out.
Right.
They even included this whole section in the paper called, don'ts.
Oh, interesting.
Basically, it was a list of all the things they tried that, well, that didn't really work out the way they planned.
I kind of love that they put that in there. It's like they're saying, hey, we're learning as we go, and sometimes, we hit a dead end.
Yeah,
Makes the whole process feel a little more relatable,
totally. And they really did a lot of experimenting with all these different variations of TransformerFAM, just trying to see how far they could push it in terms of how much it could remember
Yeah.
and how well it could generalize to new info.
So they were really in the lab, just tinkering away, trying to fine-tune this whole new engine of AI memory. What kind of things did they try?
Well, one thing they messed around with was changing how the AI compressed information. Remember those mental notes we talked about?
Yeah.
Those little summaries it creates?
Yeah, yeah.
Well, they tried having it pass along the entire output of its processing at each step, like everything, instead just that quick summary.
So instead of just highlighting the main points in its notes, it was trying to, remember every single word.
Exactly. They thought, hey, maybe that would give it even more understanding, more to work with. But as it turned out, that actually made things worse.
Oh, wow. So it seems like that ability to really sift through all the information and pick out the important bits, that's really crucial for making this whole thing work.
Exactly. It's not just about how much information AI can store. It's about how effectively it can actually use that information. It's like the difference between someone who tries to memorize an entire textbook word for word versus someone who really understands the core concepts and can then, apply them in different situations.
Yeah, that makes a lot of sense. So where does this all leave us then? What's the big takeaway, the big aha moment from this whole research paper?
And I think the biggest message here is that we're really entering this whole new era of AI research. Because for a long time, it really was all about bigger is better, more data, more processing power, just kind of throw it at the wall and see what sticks.
Right, right.
But TransformerFAM, it's kind of like this signal that we need to be a bit more elegant about it. We need to focus on how these systems actually learn and adapt.
It's like we've been trying to build a skyscraper by just stacking bricks on top of each other, but now we're finally starting to think about the blueprint, the actual structure that makes it all work together.
That's a great way to put it. And it's incredibly exciting because it opens up so many more possibilities.
Yeah.
If we can crack the code on how biological brains learn and remember, then we can start building AI that's not just intelligent, it's adaptive, it's creative, maybe even, dare I say, conscious.
Whoa, now those are some big ideas. And I guess that's what makes this whole research area so fascinating. It's not just about making AI better at processing language or winning at games.
Right.
It's about understanding the very essence of intelligence itself.
Exactly.
And that's a journey that I think we're all on together, whether we're, AI researchers, computer scientists, or just people who are curious and trying to wrap their heads around this crazy, rapidly changing world.
I couldn't agree more.
Well said. And on that note of endless curiosity, we're going to wrap up this deep dive into the world of AI and memory. But for everyone listening out there, remember, this is just the beginning of the conversation.
It is.
As always, keep exploring, keep asking questions, keep pushing the boundaries of what's possible. Until next time, stay curious, everyone.